All right, so let's just kind of review key features all together. We're going to talk about domain, we're going to talk about range, we're going to talk about increasing, decreasing, talk about end behavior, we're going to talk about intercepts, we're going to talk about maximum minimums, we're going to talk about positive, negatives. So we're going to talk about all that stuff. So let's say that you're given this equation over here. So I have f of x equals negative 2x to the fourth plus 2x to the third plus 3x squared and minus 2x plus 1. So the first thing I'm going to do if I'm given an equation like that is I'm going to go to Desmos and I'm going to plug that equation into Desmos. You can type in f of x or you can type in y equals. Either way will work. And I'm going to look at my graph. Now, the first thing I'm going to do is I'm going to find those points that are significant in determining my key features here. So I'm going to do a little bit of highlighting more at the beginning. First thing let's talk about the domain and the range. So when I think about the domain, I'm thinking about how far left to right, and then for the range, I'm thinking about bottom to top. So when I'm looking at my range, so down here, these particular ends are going to keep going. Okay, so if I were to scroll in Desmos, I would see that they're going to keep going and they're going to keep going down. But the thing about it is as they keep going down, they are going to keep getting wider. So as they keep getting wider, they're going to keep going out in both directions, which is going to affect the domain for us here. So when I'm looking at the domain, okay, I'm coming from the left. So the left side has an arrow. And I do have some points here. So I'm going to kind of draw or point as I'm talking. I'm coming from the left arrow. And yes, there's some points, but there's nothing that's not included. And it's going to continue to go to the right. So my domain in this particular problem is going from negative infinity to positive infinity, are all real numbers. Okay? So domain here is going to be negative infinity to positive infinity because there's no x values that are not included in this problem. All right, so then for the next one, we're going to talk about the range. Now the range is from the bottom, so remember we still have arrows here, from the bottom to the top. Now, I have arrows coming from the bottom, so I know that that is coming from negative infinity. It's going to keep going up, and there's no y's that are not included until we reach this point right here. So this point is where this graph stops, this one right here. So when we're talking about range, remember we're talking about the y values. So when I look at my range here, I'm going to be looking at the y value of that particular point, okay? So the y value here is going to be from negative infinity to 2.713. And the reason it's 2.713 is because that was the point that we just determined in that top point. Now, let me correct myself here because I have a point that is included. If you realize that as I was talking, good for you. This point is included, so since it's an included point, I can't use a parentheses here. I need to use a bracket. The only time I would use a parentheses is if that point was not included. Okay? So now let's talk about we've talked about domain and range. Let's talk about end behavior. So my end behavior in this particular problem, we're going to look, you're asking yourself the question, where do my left end and where do my right end go? Okay, so where do my left end and where do my right end go? So here's my left end, here's my right end. Okay, so for end behavior, you have to define it both ways. So on the left side, so on this left side, so this is left, as it goes to the left, it's going down. So as x approaches negative infinity, well, why negative infinity? Because we're going to the left, this means left. My y value is approaching negative infinity. Why negative infinity? Because it's going down. So this means left, this means down. All right, so now let's talk about the right side. So as my right side, so this is on the right side, This one is also going down. All right, so as x approaches positive infinity, my y is going down, so it's going to approach negative infinity. So this one represents left, or excuse me, not left. This one represents right. And negative infinity means it's going down. So you're simply, honestly, you're just telling me, is your left going up or down? Is your right going up or down? We're just going to use infinities. And sometimes you'll actually use values. I should have an example where that shows that in a little bit. All right. So we've done end behavior now. So now let's talk about my intercepts. So my intercepts, I have my x-intercept and I have my y-intercept. So my x-intercept is where my graph crosses the x-axis. These can be called roots, they can be called zeros, they can be called a lot of things, but x-intercept means where it crosses the x-axis. So I have 2 points where it crosses the x-axis. Okay, so I'm going to highlight those so we can see them really well. So we have this point and this point. So therefore, I have 2 x-intercepts, and those are at the point negative 1.209 and 0. And the other one is at 1.652 and 0. And yes, my y should be 0 because they are x-intercepts, so that's where the y value is 0. So then we have our x-intercept. All right, so if we're looking at our x-intercept, or our y-intercept, we're looking at where the y-axis is going to, our graph is going to cross the y-axis. All right, so if I'm looking again, I see where it crosses the y-axis. You should only have one of these. In order to be a function, it can only have one y-intercept. So that one is at 0, 1. All right, so let's talk about some increasing and decreasing. So for increasing and decreasing, you're talking about what intervals are my graph increasing, what interval are my graph decreasing, okay? So when you read this, you read it from left to right. So I'm coming from the left, so I'm going to kind of mark it as I'm going up. So I should be able to see that I'm going up here. So it's going to keep going up until it reaches that point. Now, as I change and that point changes direction, I'm now going to be decreasing. And then at that next point, I'm changing direction again. I'm just going to be increasing. And then finally, I'm decreasing again. So I'm actually increasing twice here and decreasing twice. All right. Now, when you talk about these points, you have to talk about them in terms of intervals. Intervals are going to be your x values. So when you do this, you're going to be looking at the x values that they are changing direction. So you're going to be looking at these boundaries right here, those x values. Okay? So increasing. We started increasing, and we started doing that but from negative infinity. And we stopped increasing at this point, which is the x value. So we stopped increasing at negative 0.735. All right, then we started to decrease. Now, we started decreasing at the spot where it stopped increasing. So we're going to start at 0.735, that x value, and we continue to decrease until this point, which is an x value of 1. All right, then we started to increase again, and we are going to be increasing from 1 to the next point, which is 1.201. And then we started to decrease again from 1.201 to positive infinity, because we're going to keep going to the right. All right, so I had 4 sections of increasing or decreasing. So I had 3 turns basically from where I changed. All right, so then let's talk about maximum minimums, because maximum and minimums are going to be relating to your increasing and decreasing, because those points are significant. Okay, So I'm going to kind of erase the black marks that are the black lines that I made, and hopefully hopefully we can see just a little bit better here. All right. So we do have that highlighting there still. So here's my increasing sections and my decreasing sections. Not that it really is going to matter so much, but when we talk about max or minimums, it may be easier for you to see. So maximums. So we have two types of maximums or minimums. They're called extrema, okay? So my extrema are going to be my highest or my lowest points. I call them my valleys and my hills. So when I'm looking at this particular problem, I see three extrema points. I see a point here because I have a hill. I see another one here, I have a valley. And I see another one here because it's a hill. Now, a lot of students try to say maximum minimums are going to negative infinity or positive infinity, and that doesn't work because in order to be a maximum or minimum, it's where it changes from increasing to decreasing. You can see that these color changes, all three of these points are changing, increasing to decreasing. Now, I have two maximums. I have an absolute maximum. So absolute means it's absolutely the highest point. This right here is that absolute maximum. So that absolute maximum is at negative 0.735 and 2.713. That is absolutely the highest point of the graph. There's nothing that comes above it. You can even look at the range because the range says that. Then I have a relative maximum. That is right here. It's still a maximum because it's still a hill, but it's not the highest. So that's at 1.201 and 2.229. And then finally, I have a minimum. Now, that minimum is a relative minimum, and it's relative because it's a valley, but it's not the lowest point of the whole graph. If I continue to go to infinity, it can't be the lowest point because my graph's going to keep going down. And that point is going to be at 0.283 and 0.707. So I have three extrema points. And the last thing that we're going to talk about is we're going to talk about our positive and negative values. Now, positive can be defined as anything that's above the x-axis. So any section above the x-axis is positive. So all this right here is positive because it's above the x-axis. Anything below the x-axis is negative. So these two sections are below the x-axis. So when we say that, we've just got to state it in such a way that represents that with an interval. So positive. So positive starts at this point. The x value for that is negative 1.209, and it continues to be positive until 0.283. That whole range right here, that's all positive. Those x values in that range. All right, and negative. So negative is in two separate sections, so we're going to have to write it as such. So my negative is everything that's from negative infinity to negative 1.209, because that's that x value cutoff right there. And it's negative right here from 1.652 to positive infinity, because it's all the rest of this down here. Now, there was a lot going on in this graph, but I hope this kind of helps explain a little bit more. I do have a few more examples. I may not do everything about those examples, but I'm going to do some things that kind of stick out in my mind as important. All right, so looking at this one, let's definitely talk about the domain and range here. So remember, domain is going to be left to right. So when I'm reading my graph here, first thing I see is this open circle at -3. So that open circle tells me that I'm going to have a parentheses here because I have an open circle. And my graph is going to continue to go to the right until this closed circle. So I'm going to need a bracket. And everything in between is included. So my domain is going to be from -3 to 1 bracket. All right, so my range here. My range in this particular problem, I have a point here and a point here. So I do have a value at -4. That is a bracket. And it's going up to, now I have an open point here, but I do have the value 0 that's closed here. So that's still going to be a closed point. As long as I can find a closed point, it's still closed with another bracket. So this is going to be from -4 to 0. Now, I do have some minimums here. I have a relative, well, I guess we could call this an absolute because that is the lowest point, even though this one is here too, but that's not a minimum. This is a minimum here. It's an absolute minimum. And then this one right here is going to be an absolute maximum. This entire graph is actually negative because it's all below the x-axis. I have decreasing here, so it's decreasing from -3 to 2. It's increasing from -2 to 0. And it decreases again from 0 to 1. Okay? All right, so let's look at the next example. So we're talking about my domain again, so from left to right. So I have this open circle. There's nothing that can fill it in. So I have an open circle, which means I have a parentheses, and it goes to the value over here with a closed circle, so that's the bracket. So my domain is going to be from -2 to +2, parentheses, bracket. My range, I have two closed circles here, so this is going to be closed, and it goes up. So yes, I have an open, but then I also have a closed, so that's going to close it in, and those are going to be two brackets as well. So this range is going to be from -5 to +4 with brackets. These are absolute maximums right here, or excuse me, absolute minimums. I do have a maximum right here, but that one is going to be a relative maximum. And if we're talking about increasing and decreasing, so this is decreasing from -2 to -1. It increases from -1 to 0. It decreases again from 0 to 1. And then it starts to increase again from 1 to 2. So let me kind of write that out to make sure we can clearly understand that. So we have increasing, decreasing. So it decreases. It starts to decrease right here at an x value of -2, and it stops decreasing at 1 right here. Then it increases from 1 to 0. It decreases again from 0 to 1, and it starts to increase again from 1 to 2. So remember, when you're doing increasing and decreasing, it's the interval, so it's the x values. All right, and for this particular graph, I did want to address this and talk about domain and range and end behavior. So when we're talking about the domain and range here, there's a couple of things that we need to actually label here. And we have what we call asymptotes. You know, of course, everybody thinks that word's really weird, but basically it just means an invisible boundary. So sorry about that, I messed the keyboard up. Invisible boundary. So an invisible boundary is like we can clearly see that this graph is not going to cross over that particular line. So if I look right here, I can see that there is an invisible boundary that is horizontal. And I can also see an invisible boundary that is vertical, which means that that line is going to get close and close and close as it can to it, but it's never going to cross over it. Okay, and those invisible boundaries, those asymptotes, are going to take away from the domain. So it actually is going to affect the domain and the range. So when I'm talking about the domain here, okay, So my domain is coming from an arrow, so we're going to be coming from negative infinity, but it stops right here at this asymptote. So we have a boundary that is not included. So the domain is coming from negative infinity, but it stops at that boundary, and that boundary happens at -3. So we go up to I call it a fence. I go up to the fence. So we're going to come up to this fence and approach it. And now we're going to go to the other side of the fence and continue on. So we're going to union that with -3 on the other side. So we went up to the fence at -3 on the left. Now we're going to continue on the other side of the fence at -3 to the right. And we're going to keep going until we get to positive infinity as we keep going this way. Okay. Now, the range. So the range, let me kind of wash or clean this off a little bit and kind of make it easier to see as we're talking. So we did have this vertical boundary here, and we had this horizontal boundary here. All right, so same thing with the range here. We're going to think about it the same way. So we're coming from the bottom, so we're coming from negative infinity, and we're going to keep going until we hit this invisible fence here. That invisible fence we're going to estimate is at 3. So we're going to hit that fence at +3 on the bottom side of it. Then we're going to pick back up on the other side of the fence at 3. So we're going to union, and we're going to go up to infinity. All right, so then we have some end behavior. I really like to talk about end behavior with these types of problems. So where are my ends? Because I see 4 different arrows. So the ends are whatever ends are on the far left side or the far right side. So the far left is this end. So this is the left. And this far right side is the right side. So if we're talking about end behavior here, so this left side is going down. Even though it's going out to the left, it's still going to keep going down and down and down. So this is going to be left and down. So as x approaches negative infinity, that's left. Remember, that means to the left. Y is going to negative infinity, which means down. All right, so the right side, as my x goes to infinity, y to infinity, because that's the right, my x's are going up. So as it goes to the right, it's still gradually going up, which is positive infinity. Okay. The only other thing that I wanted to look at real quick is what happens if I have a point on my far end. So let's say I have my graph here, and let's say I have this quadratic here. But this quadratic, this parabola, has an ending value. Let's talk about domain and range end behavior. So my domain is coming from negative infinity. So if I'm highlighting here, it's coming from negative infinity, and it's going to this point. That point is closed, so we're coming from negative infinity to this point. So negative infinity to 4 with a bracket. All right, my range. We're stopping right here. So we have this closed point, and we're going up to infinity. So this is going to be at -2 with a bracket because it's closed, and then to infinity. Now, end behavior. This is one of those situations where your end behavior may not actually be to an infinity value. It may not be to infinity or negative infinity. It may be to an actual numerical value. So where are my ends? So here's my left end. All right, so here's my left end. Here's my right end. My right end is going to be different because my right end is an actual point. All right, so left. As I go to the left, so as x approaches negative infinity, it is going to go up. So that one's pretty simple. That one's still going to be going to positive infinity. So this is left and up. Now the right end, this one's different. I'm not going to infinity. I'm stopping at this point. So what x value is this point stopping at? Well, my point is 4, 4. So as x is approaching 4, because there's a point there, My y value is approaching 4. How do I know? Because I have the point that's x and y. I hope this video kind of clarifies everything together. If you still have any more questions, please let me know, and I'll try to help you as much as possible.